So this is the second part of the problem from the previous video where we discussed number 1 through 5. Number 6 and 7 refer to the same diagram. 4 vertical stabilizing cables are being installed on the aforementioned bridge to help support the bridge in windy conditions. 2 of the cables will be installed 150 feet away from each support tower. So if I'm trying to draw those in, so I know this is 300 feet from here to here. If a vertical cable is being installed 150 feet, that's halfway, so right there. And then it's 150 feet away from each tower. So one there and another one here. And 2 additional cables will be installed 60 feet away from each tower. So 60 feet away, so if this is 150, it'll be a little less than halfway. And I'm just sketching it here. So this right here is at 60. This is at 150. And then over here, this is 60 feet away from here. So this is at 540. And this is 150 feet away from here, or 350. Or, sorry, 450. So the next question says, what equations can model these new cables? We have vertical lines, so if we're coming up with an equation, we already know the x values that have been labeled here. So x equals 60 is the equation of this vertical line. X equals each of these other values as well. So maintenance workers have a total of 160 feet of cable to cut apart and use for the new vertical stabilizers, but they're not sure if they have enough cable to complete the job. How can you determine whether they have enough cable? So if I'm trying to figure out the total length of cable, I need to know the sum of all of these pink cables that we drew in here. But if I'm trying to find the length or the height of these, I need to calculate the y value at these points. But if I can find the lengths of these two, it should be the same on this side because these are symmetric. So when x equals 60, I need to calculate the y values. We have an equation right here, so if I plug it into that equation, y equals 1 over 900 x minus 300 squared plus 0, so we can calculate that. And we're going to do the same thing when x equals 150. We're finding the length or the y value. So y equals 1 over 900 x minus h squared. So if we just type that all into a calculator, make sure you put the fraction in parentheses, so 1 over 900, and then 60 minus 300 squared equals 64. And then this one right here, same expression except is 150 minus 300, which is 25. So if we look at the total length of all 4 of these and answer the question, do they have enough cable, I have 64 feet plus another 25 feet, plus these two, which are the same length, so plus another 64 and another 25. If we add all that up, that's 178 feet that are needed in cable. However, originally the maintenance workers only have 160 feet of cable, so this is a no, not enough cable to meet this need. Question B right here, how can you use your calculator to help you answer the question? Describe what features you could use. So here we did this algebraically. If we graphed our equation, we could check to see what y is equal to on the graph when x equals 60 or when x equals 150.